All right, so for today's lecture, we're going to be covering unit testing in Python. This is going to be our last formal lecture for this first term of the PPiAI coding course. We'll still have, our sessions from here on just to go over the final projects and stuff. But this is going to be our last actual lecture where I'll be teaching you stuff, and the rest of it's going to be more of self-study, and you'll ask me questions as you have them. So yeah, let's go ahead and get started. All right, so testing in Python. There's a number of different ways that you can test in Python. The I guess not most common, but the one that you always start out with is manual testing. Manual testing is just manually running code with various inputs and observing outputs to ensure they match your expectations. This is what we've been doing so far. It's relatively simple and intuitive. Once you know how to run a program, you'll write your code, run it, make sure it works the way you thought. Um, and that's really all there is to manual testing. But it can be quite time consuming because each test requires creating different inputs, digging through outputs to verify, and digging through outputs to verify the functionality. If you make a single change to your program, you need to manually test each scenario again, which can be time consuming. And it's hard to keep track of which tests have I run since my last code change. And coming up with a testing plan for manual testing can be quite time and resource consuming at that point. But there's also automated testing in Python, and that's basically testing your code with other code. There is a good bit of upfront work still. You still have to define your test cases just like you do in manual testing. You still have to gather all the inputs and all that stuff just like you do for manual testing. But once you have all those inputs and all that good stuff, then you have to write a few functions, and you write those functions that exercise your code, and your code will then programmatically verify the outcomes. So you have to put in that upfront work of defining your test cases, getting all your inputs, and writing the code to verify the outputs from your program. But once you have those those functions written, then if you make a change, retesting your code is as simple as rerunning your testing script. And rerunning your testing script is always going to be a lot faster than doing manual tests where you manually take input, send it through the program, and then manually observe the outputs. Because once you have the automated tests, computers can run very quickly. They can run these scenarios extremely quickly, and then you can easily see that whether or not the what you did is still meeting your expectations. So retesting code changes is super simple with automated testing. So then, aside from manual and automated testing, there's two types of testing, and you can do these types of testing with manual or automated tests. Of course, I always recommend automated tests, but sometimes manual tests are necessary. But the first type of testing is called integration testing. Integration testing tests how all of the components of a program work together. It's essentially testing your entire program, or testing how two components of your program interact with each other and making sure that they work together the way you expected. And so you run your program. If it's not working as expected, so you run your program, say you get some bugs. It's not giving you the output you expected. It's pretty difficult to know exactly where the issue is coming from, because if you're running a whole program with, say, 50 different functions and all these different if statements and loops and all that stuff, and you just get an error that says something like, I don't know, like type error, it'll tell you the line and all that stuff, and you have to go find that line. But what caused that problem? Was it an upstream function that generated the wrong output type? Or was it something that you have hard coded that wasn't the right type? It's really hard to tell what the problem is exactly in an integration test. The traceback will only get you so far when you encounter an error. But integration testing is still extremely important. Like, that's something you should do as your last phase of testing. You want to make sure everything works together. But before you do that as your last phase of testing, a best practice is to practice unit testing, which is what we're going to be covering in today's lecture. So unit testing tests individual components or units of a program. So we don't test the entire program in a single unit test, but all of the individual parts that compose that program in distinct unit tests. So you'll want to write a test. So if you have 50, going back to the integration example, if you have 50 functions in your code, you're going to want to write at least 50 different tests to test 50 different unit tests to test each individual function of your code and make sure that it's behaving as you expect. Sometimes maybe you'll want more unit tests than that because you want to test different scenarios with each of those functions. That's always a best practice. But a unit test will just test one piece of your program, generally one function or one class or one part of a class or one piece of functionality of a specific function. So yeah, this allows you to identify issues in individual aspects of your code so we can make targeted fixes. So, going back to that integration testing example, you run your code and you get a type error somewhere in there. You don't know where that came from. But with unit testing, well, in the integration test, you'll know where it came from in terms of what line exactly it failed on, and maybe you can trace your way back through the code to find out where the error originated. But with unit testing, you'll be able to easily tell, like, oh, this function is supposed to return an integer, but it's returning a string, or this function expects a string, but it's but it's supposed to expect, like, this function when given a string, which is supposed to be a valid input, it's throwing an error. And so we need to update our code in that particular function so that it accepts the type of input that it needs. And as mentioned already, this is typically done before integration testing. You want to test each individual component of your program to make sure that it's all working as you expected, and then you can test how everything works together. Once you know that each individual component is working as you expected, then when you do your integration test, if you get an error, it's a lot easier to figure out, okay, where is this error coming from? I know that this function does exactly what I expect. This function does exactly what I expect. Maybe it's something in my main file where I'm, orchestrating these two things where I'm not doing something right there. So it just makes it a lot easier to find the exact error once you've done your unit testing first, and then follow that up with integration testing. So as mentioned, today's lecture is going to be on unit testing. So we've already done some integration testing ourselves where we run our entire program and make sure it works. We've already done manual testing a number of times throughout this class. That's basically the way we've tested our program so far. But for and then unit testing is generally you're going to implement it as a type of automated testing. So in this lecture, we're really going to be covering unit testing as automated testing, because of course you could unit test individual functions in a manual fashion, like just copy your function to your command line and play around with it. That's that's like a manual unit test, but we're going to be covering more automated unit testing here. Cool. Any questions on these different types of testing before I move on to the next slide? All right. Cool. So the first thing you need to know when it comes to testing code is the assert keyword. So the assert keyword is used to affirm that a Boolean expression evaluates to true and raises an assertion error with a specified message if it is false. So in this particular case here, I'm asserting that 4 is less than 5. So you have your assert keyword, you follow it up with a Boolean expression, and then you can put a comma here. This comma is optional. This comma and then the string after it is optional. If you're going to have the string after it, you do need the comma there. But what this does is the thing after the comma is the error message that's returned if this evaluates to false. So when I ran this didn't evaluate to false. 4 is indeed less than 5, so this evaluates to true. So we don't see this error, this string output to the console here. Alternatively, if I tried to assert that 5 is less than 4, that Boolean expression is going to evaluate to false. And then, I still have the same message, the Boolean expression is false. Now, when I run that, I get an error here, and it, gives me a traceback. I get an assertion error, and we see the string that I specified up there output in my assertion error down here. So again, with the assert, you're going to have an assert, and then after it, you're going to have some sort of Boolean expression or something that evaluates to true or false. It can be like a function that returns true or false. It can be any number of things, just it has to ultimately evaluate to true or false. So we have our Boolean expression here after the assert statement, and then we have the message if the assertion is false. Again, this message for whether or not the assertion is false isn't required. Um, but it's often helpful to have this so that when this type of error occurs in a real program, you can see exactly which line and why it failed. Yeah. And then just a call out here. This is, that message is what's output in the assertion error at the bottom when an assertion error occurs. So this can be used to verify that a function is returning an expected value. So in this particular case, my Boolean expression is now asserting that the sum of 3, 4, and 5 is equal to 12. Then my string here is the result should be 12. I run this, the sum, when I pass the list 3, 4, and 5 to the function sum, that just sums up every element in that list. It does in fact return 12 because 3 plus 4 plus 5 is 12. And so this Boolean expression evaluates to true. We don't get any output here in the console. But if I, mistyped and I put 3, 4, and 6 in my list, that's going to add up to 13. 13 does not equal 12. So this Boolean expression here evaluates to false, and we get an assertion error here. So it says the result should be 12. So we can use this to verify that functions return an expected value. We can also use this to make determinations inside of our code itself. Say within like a function, we want to make sure that someone's passing us an integer, or like in the case that we're getting user input. Something we might want to do when we're getting user input is say we ask them to enter how old they are. They enter 30. We know that the input function inputs everything as a string. So we might want to then have an assert after that to assert that that number entered is, or that string entered is a numeric string. And we could use the isNumeric function there, and we could assert that the value entered is numeric. If it isn't, then we can raise an assertion error and ask the user to re-enter the code or re-enter their age, because maybe they typed out the word 30 instead of the numbers 30, things like that. So asserts can be used within your code, and it can also be used as a form of testing. You'll often see it as a form of testing, but it's also a great way to do data validations within your code. Yeah, so any questions on the assert keyword? Cool. All right, so let's talk about the unit test package. So unit test is a unit testing framework inspired by unit testing frameworks from other languages. So Python's a relatively new language compared to some other languages. The Java programming language that I'm sure you've heard of before. Oftentimes you have to install it on your computer for various software to work. That has a unit testing framework called JUnit. Unit test is based on the JUnit unit testing framework. That's where it got its inspiration. So this unit test package often comes pre-installed with your Python distributions. So this is something that you won't need to pip install. Generally, I guess there are going to be some cases where you just have the Python executable itself and you do need to install unit test. Just go back to last week's lecture if you do need to install it. You can just do that with a pip install. But you can import it into your unit testing file as you do in other packages. And your unit testing file should be its own file. We'll see more about that later. But you don't want to have like a unit tests integrated into your same file as the code that you're trying to test. You want them logically separate. But this is how you would import it. So you just import unit test. It's just a module essentially. So import that and you're good to go. Once imported, you can create a class that is a subclass of unit test.test case. So this is like your test case. It's going to be your class of all your testing scenarios essentially. So you create a class, you give it a name, and excuse me, and in order to make it a subclass of unit test.test case, you pass unit test.test case into the parentheses of your class definition. So this is how you define your unit testing test case and collection of testing scenarios, essentially. Then you define methods within that class to perform your various tests. So in this particular case, I called my class test list methods, passing in unit test.test case to make sure that this is a subclass of test case. And then within there, we define methods. So remember, methods always have to have the self argument as its first argument. And then, so in this case, I'm going to test sort because I'm testing list methods in here. So I take my list, I define it as 5356863, and then I take my list and I sort it. And then I can do self.assert equal my list. And then, so this is the list that I want. This is my list that I've sorted, and then I want to make sure that it matches a sorted version of that list, 3355668. And so what this does is it essentially in the back end, this is like a method that takes two arguments and it asserts that those two arguments are equal using the assert method, the assert keyword that we saw previously. But this assert equal is actually a method of the test case class. So since this is a subclass of the unit test.test case class, we have access to these methods that are part of the test case class. So we have access to assert equal, and notice we have to use self.assert equal because we're essentially calling it on itself. We're calling the assert equal method from our test list methods class, which inherited this assert equal method from the test case class itself. So we have to do self.assert equal, pass the list that pass the thing that we want to verify is equal to something here, and then what it should be equal to as the second argument. And then we can define test reverse, again, self as the argument there, because this is a method of a class, so it needs to have self as its first argument. Define my list as that same list. Now I'm going to reverse that list. And here I can do multiple assertions. So first I want to assert that it's not, that my list isn't equal to what it was originally. So it's no longer equal to 5356863 because it should be reversed. And then I can assert that my list is equal to 3686535, which is the reverse of this list. Yeah, so we have various different assertion methods that come from the test case class, and we'll go over a few of the options and how to use them in a future slide. But any questions on the general structure for how to use the unit test package, create your test class, and then start creating test methods? All right, great. Oh, and just one thing on naming convention here. So you'll notice I put test underscore. So typically with unit tests, you'll want to prefix it with the word test, and then you'll want to mention what you're testing after that. So here I'm testing sort. I know we're in test list methods class, so I'm testing sort. That I'm testing the sort method from list methods. Here I'm testing the reverse method from list methods. So that's typically what you're going to want to, the naming convention you're going to want to do, test underscore, test underscore whatever you're testing. Cool. Right, so the unit test package continued. Once your tests are defined, you can run them in a few ways. You can run the file itself via your PyCharm IDE. So here I have my example.py file. I've imported unit test. Here's my test class called test list methods. And it's inheriting from unit test.test case. These are the test methods that I had created on the previous slide. This is just showing my whole PyCharm IDE. So you can run the file itself from your PyCharm IDE. You can do that using this play button up here. That'll just, since I've selected the example.py file, if I click run, it'll just run that file, and it'll execute all of the tests in here. You can also selectively run individual tests using the run. So you can selectively run individual tests using the run button near the file line numbers. So those are these buttons over here. So if I click this run button here, it'll run this test and only this test. If I click this run button, it'll run the test reverse test and only that test. I could also click this play button up here and it'll run all of the test methods under this test class. But it's almost the same thing as just pressing this button up here. Yeah. Then another option is we can run your tests from the command line. This is how I typically do it personally. I like the output that I get to the command line a little better than the one that outputs to the console. It's a little bit more readable. There's a lot less noise going on when you do it in your command line interface than from running here or here. This particular case is helpful for just testing individual methods and just seeing if it passes. And then this one, for me, I personally prefer to do the command line than run it up here. But, totally up to you. Just try them both, see what you prefer, and go from there. But if you are going to run it from the command line, you need to specify Python or Python 3. If you're on a Mac, you will need to specify Python 3 because otherwise it's going to try to use Python 2. And then if your example.py file or whatever Python file that contains your tests is written in Python 3 and you use just Python here on a Mac, it'll use Python 2 and you'll get some issues. But here you do Python or Python 3 -m unit test example.py. So what I'm doing here is I'm essentially calling the unit test package. I'm saying to run the example.py file using Python 3, and that'll execute all of the tests that are within my example.py file. You can also run just for other informational purposes. If you ever want to run a file from the command line, you can do the same thing here. Just get rid of the -m unit test, and if I just did Python 3 example.py, it would just run this file and everything within it as well. But of course, if I just did that, then I don't have any main method to actually run these, so we wouldn't necessarily get the output we're expecting. This ensures that the -m unit test ensures that it'll execute the unit tests that you have in there using the unit testing framework. So any questions on how you can go about running unit tests? And I will demo this at the end of the lecture.
Hi, David.
Hey.
Just want to know, the unit test package, is it written in Python?
It is, yeah.
So basically, they are helping us
Correct,
program
exactly.
better.
Exactly, yeah. So unit test, it's
Okay.
one of those open source packages that's widely available for people to use for free in Python. It's written in Python, so you can also, if you're ever interested, you can open it up and dig into the code of unit test and learn about what's in it, how they designed it, how they implemented it, all that good stuff. But yeah, Python has a great open source community. Someone took the time to create a unit testing framework, and we're able to now just use that in our code, and it makes unit testing a lot easier than it would otherwise, essentially. So yeah, great question. Any other questions?
Thank you.
Of course. All right, cool. So unit test package continued again. When you run your tests, you'll get an output to the console indicating the results of your tests. So I ran this from the command line. It's a little more readable. I'll show you both in some time, but generally, I ran it. Just imagine that line that I saw that I had at the bottom of the last slide. Just imagine that right up above here. I executed that, and then we just see ... lines on some lines, ran 2 tests in 0.000 seconds, and okay. So what this means is that my tests passed. If any of them failed, I would see an F instead of a dot for one of these, and it would tell me that something failed, and it wouldn't necessarily say okay down here because the okay means everything ran okay. There weren't any issues. But if any of the tests fail, the test report will say so. So here I've removed from my test reverse, I've removed my my list.reverse here. So now I'm not reversing the list. So both of these assertions will evaluate to false. Or both of these assertions are going to cause a problem here, essentially. Yeah, because since I never reversed the list, my list is going to be equal to this. So this is going to cause an issue, the first one. And if it got to the second one, that would cause an issue as well, because it's no longer a reverse list. So so asserting that they're equal just doesn't make sense because it hasn't been reversed. So if I comment that out, or if I forgot to put that line in there for some reason, and I run that test, then you'll see here I get an F and a period. So up here we just saw 2 periods that meant it passed successfully, but here we see an F indicating that one of the tests failed, and then another period meaning the other test still passed. and then it'll say fail here. It calls out which test failed, and it's saying that it's from my example file in my test list methods class. And then we have the traceback here, and it shows the file example.py. It says line 14 in test reverse. So it's saying that it happened on in line 14 of my example.py file in the test reverse method. And it calls out the exact line. So this self assert not equal my list to 5356863, that created an assertion error because these two lists are equal. So my list is equal to that in this particular case because I never reversed it. And so it tries to tell you as much information as possible about what your error was. It gives you a trace back there. So here it says ran 2 tests in 0.000 seconds. This is just, it just tells you how long it took and how many tests ran. And then it says it failed and I had 1 failure. So, 2 tests ran. So it says 2 tests ran here, and we can see up here that 2 would run. 2 tests ran and I got 1 failure in there. So that's what it'll look like if anything fails. And this is what comes out when you do it from the command line. I'll show you what it looks like from if you run it from PyCharm and what that output looks like in the console there. I think it's a little less readable personally, but again, totally up to you, whatever you prefer. Cool, so any questions on the output that you get when you run a test and the distinctions between passing and failing tests? Cool. All right, so unit testing methods. So the unit test package comes with a number of built-in methods to use in your unit tests. So we've seen assert equal. It takes the actual value and expected value, and you can optionally pass a message. In my example so far, I didn't pass a message, but just like with the assert message, with the assert keyword, you can add a message after the comma. You can add a message as your third argument to most of these assert methods, and that message is what will be returned in your assertion error if you get one. Otherwise, not passing a message like we saw here, it just calls out, assertion error, these things are equal. And if you look at the method, you can see that we were trying to assert that they're not equal. So we get a problem there. But yeah, so that's assert equal. It asserts that 2 values are equal, the first value passed and the second value passed. Typically, it's good convention to put the value that you're testing and then the expected value for the second argument. Yeah. And then assert not equal, as we saw, it's the opposite. You pass an actual value, you pass an unexpected value and an optional message, and it asserts that the values are not equal. Yeah. So assert false, you can put in a Boolean expression here or like some output from a function that would return a Boolean and an optional message as well. And this asserts that the Boolean or Boolean expression is false. So if you have a function that's supposed to return true or false, you can pass its output here and assert that it's false if you're expecting it to be false. And if it's not, then you'll get an assertion error. Alternatively, we have assert true. So basically same thing as assert false, except checking that the Boolean or Boolean expression is true. Assert in is a way that you can verify that some value is in some container. So it asserts that a value is a member of a container object. So the first thing that you pass is the value that you want to make sure is in your container object. And the second thing you pass is the container object itself. And then third, there's the optional message to pass. So say you want to say you have some function that generates a list of values 1 through 10. Maybe you want to assert that 10 is in that list. You could use assert in, put the value 10, and then your output list from that function, and assert that 10 is in that list. If it's not, then it'll raise an assertion error because maybe you're using the range function and you forget that range is exclusive to the upper bound. So you try to do range 10, then 10's not in your list. You'd get an assertion error there. You need to go in and fix your code. So assert less, it asserts that the first value is less than the second value. So you would pass some value here, some other value here, and an optional message. So whatever value that's passed first is the value that should be less than the second value. So if if you have a function that returns some decimal number between 0 and 1, but not 1 itself, so the highest it could be is 0.99999 whatever. Maybe you do the return of your function here, and then like the value returned from your function here, and then 1 here, and you want to assert that that the value you got is always less than 1. So that's one way you might use assert less. Assert less equal is like assert less, but it asserts that the first value is less than or equal to the second value. So just like assert less, maybe you do want your function to be able to return up to 1. You always want to make sure that it's less than or equal to 1. You could use assert less equal for that. Assert greater, it asserts that the first value is greater than the second value. So just like assert less, except the other way around. You would want this value to be some greater value, this to be some less value, and of course it's based on your expectations. So yeah, and then assert greater equal asserts that the first value is greater than or equal to the second value. Yeah, and then assert is instance. So this one, it takes a value, an object type, and a message, and an optional message. So it asserts that the first parameter is an instance of the object type passed in the second parameter. So as we were talking about earlier, say you have a function that's supposed to return an integer. You could use assert is instance to assert that the value returned is in fact an integer value by passing the value returned from your function here, and then int here, the int type here, and then running this would verify that that value is in fact an int, and if it's not, then it'll raise an assertion error. Then the message parameter is used to specify a custom message in the case that an assertion error is raised. So just like I showed way earlier with just the assert on its own, you can have the assertion. You can have a custom message essentially. So this is like your custom message that would be output in the case that an assertion error is raised. Yeah, any questions on those unit test methods?
David, I just wanted to know the assert is instance. I didn't hear well. Can you please explain again? Assert.
Yeah, so the assert is instance. Asserts that the first parameter is an instance of the object type passed in the second parameter. So say you have a function that's supposed to return a string. You want to verify that it is returning a string and it's not returning like an integer or some other type. You would pass, you'd execute your function, store the returned value in some variable. You'd pass that variable as the first argument here, and then you'd just do stir as the second argument here, and this will assert that the value you pass here is in fact a stir type. And I can show an example of that, and it'll raise an assertion error if it's not a stir type. Does that help?
Yes, absolutely. Thank you.
Of course. Cool. Any other questions on unit test methods? All right, great. So you can test your custom functions with unit test. So you test your own custom code via the unit test package by creating a testing file and importing the functions you'd like to test into the testing file. So here I've created this program, and within my program I've created 2 functions. These are actually functions from a previous lecture, I think, when we were talking about functions. So I have my def get user greeting, takes a name and optional greeting, otherwise it defaults to hello, verifies that the greeting is one of these greetings here, and then it returns that greeting there. And then another function, get integer quotient and remainder. So it takes a dividend and a divisor, and it does integer division, taking the dividend divided by the divisor and returning the integer result of that. And then it returns the remainder as well, the dividend modulus the divisor, and that just returns the remainder of dividing whatever the dividend is by that divisor. So then in my testing program, I import unit test still, And then from my program, so I'm treating my program.py file as a module here. And so from that program, I'm going to import the functions that I want to test. So I import get user greeting and I import get integer quotient and remainder into this file. So now it's available in my testing program file for use in my unit tests. Yeah. So this is just like what we talked about last week with modules and packages. You need to kind of treat your program file as a module, and you import the functions from that module essentially. The functions that you want to test, you would import from that file. So then in your test program, just expanding it more, once you've imported your code into your testing file, you can use them within your testing class to validate their functionality. So I've imported, as we saw in the previous slide, I've imported get integer quotient and remainder and get user greeting into my test program .py file. I have my test program functions class. Unit test.test case is, so it's subclassing, it's a subclass of unit test.test case, inheriting all of the testing methods that are available in the test case class. Oops, did not mean to do that. And then in here, I define two testing methods. First, I'm going to test get integer quotient and remainder. And I just realized I accidentally flipped the names here in this screenshot. So that's my bad. Let's imagine that this is test get user greeting here. So we have greeting equals get user greeting, passing world. And then I'm asserting that the greeting is equal to hello world. And then I'm passing this message here in case the assertion fails: unexpected greeting returned, expected hello world, but got, and then it'll output the greeting there so that I can see what the, so I know what my expectation was, and then I know what my actual output was here. And then in this test down here, again, we're going to imagine that this is test get integer quotient and remainder. Here I'm going to, set quotient and remainder to my get integer quotient and remainder 10 and 3. So my dividend is 10, my divisor is 3. So in here now I'm going to do multiple assertions here. First, I want to assert that my quotient is an int. So I'm expecting quotient type to be integer, but I got some other type. So I formatted in the type of my quotient there, so that if this fails, I'll know what the type is of my quotient, and I can, use that to figure out why this isn't working. Then I want to assert that my quotient is equal to 3. I expect, and then my message here is expected quotient of 3, but got, and some other value for my quotient. And then again, I'm going to assert equal that my remainder is 1, because 10 divided by 3 and grabbing a remainder there has a remainder of 1. So I expected a remainder of 1, but I got some other remainder, and it'll output that, and it'll format that in there so that if this does raise an assertion error, I can see what my remainder did evaluate to, and I can go into my code and fix that as needed. So any questions on this? Okay, cool. So that's really it for the slides today. Some additional resources here, getting started with testing in Python from realpython.com. They have some useful information on testing in Python. If you want to read up on the documentation of the unit test package, you can do so at this link. There are other unit test methods that I didn't call out here, and there's other ways you can use the unit testing package than what I've showed so far. If you want to learn more about that, you can go to this link. Otherwise, what you know so far should be enough to get you where you need to go, especially for the assignment. It'll definitely be enough for that. And for most unit testing use cases, you've got the information you need from the lecture, but definitely check it out. It's always worth the time. And then if you're interested in exploring another unit testing framework, PyTest is another unit testing framework, and there's a link to PyTest documentation. I really like PyTest. I use it a lot at work. One of the big advantages to PyTest is that you can run all of the unit tests that are within a folder. So say you have a folder of a bunch of different unit tests, or a folder of folders, and each folder has a bunch of different unit test files for different functions or for different programs that you're trying to test. PyTest can recursively go through all of those folders and execute all those unit tests. And it can also generate like a test coverage report, like something that you might hear about if you get into the field of computer sciences, test coverage. And that's, you know, how much of your code is covered by unit tests, how much of it has been tested by a unit test. And it's generally a good practice to get your test coverage as high as possible, but sometimes it's not always practical. Certain things, it doesn't make sense to unit test. So you don't want to just get your coverage up there to 100% just as a vanity metric. But it is generally a good practice to get it as high as you can. Cool. Any questions on the slides for today before I review the assignment?
So David, instead of using unit tests, you can use PyTest then.
Yeah, that's correct. Yeah, it's another open source
Okay.
unit testing framework. There are some differences with it, so you'd have to read through the documentation to make sure you understand how to use it. It is relatively simple or relatively similar to a unit test, and it is also relatively simple. Yeah, so if you do want to use PyTest, just you know, read through the documentation, check it out. If you have any questions, I'm happy to help answer those.
So if you are using it, that means it's better.
Well, it's better in certain cases. So for me, the reason I use it at work is because, you know, at work I have a project that has you know, it has tons of different files, tons of different programs, tons of different pieces of code that are separated. And generally you want to test each thing in its own testing file. Because of how much code we have in our project at work, we have, you know, all these different testing files, they're nested in different folders and all that stuff. And, you know, unit test was working great for us for everything that we needed until we got to the point where we needed to be able to recursively dig into different files to execute all of the tests in those different folders. And that's where PyTest won out over unit test. So, you know, I actually used unit test pretty much exclusively until it got to the point where it was like, we need a way to run all of these tests at once, and we need to get a coverage report of all of these unit tests, like to get the coverage of our entire code repository. So let's use PyTest for that. But it integrates well with unit test. So you can still use PyTest for running tests that are written using the unit test framework. Does that help answer your question?
Thank you. Absolutely.
Okay. All right. Hello, David.
Hey.
Can you hear me?
Yeah, I can hear you.
Okay, please. I want to know if you can, if the PyTest is pre-installed like the unit test.
PyTest isn't.
The import PyTest for you to get it into your function or into your Py.
Yeah. So if you want to install PyTest, oh, I have the wrong PyCharm open there. Let me get the right one over here.
Okay.
So if you want to install PyTest, you can, you know, go to PyCharm preferences, your project interpreter, hit the plus here, and search for PyTest up here, and then you can install it using the install package here, or you can install it using pip, like we talked about in our last lecture. I could do like a pip 3 install PyTest, and it would install it that way as well. So it doesn't come pre-installed like unit test does, but if you would like to use it, that's how you can install it. Great question.
Okay, thank you.
Yeah, of course.
Sorry, David, can you go back where you found it before? Not typing, but you went somewhere. PyCharm?
Yeah. So for me on a Mac, I go to PyCharm, then preferences, and then in this folder structure here, you come down to project. This often isn't expanded. You expand that, click on project interpreter, click the plus button down here, and then you can search for various packages to install here. So this only works if you're operating out of PyCharm. but it's really helpful because then you don't have to worry about, getting the pip command correct and all that good stuff. Yeah.
All right, thank you, because I'm operating out of Python, yes.
Yeah, and then on a Windows machine, it's slightly different. I think you might have to go to like File, and then there might be a Preferences in there or something. It's slightly different, but once you find the Preferences tab, it's in there.
Okay, thank you very much.
Yeah, of course. All right, let's go over the assignment for the week. So week 11 assignment for unit testing. For the assignment this week, we're going to go back to our assignment from week 8 on functions and create unit tests for the functions created in that assignment. Using your own submission for week 8, create unit tests to verify the functionality of the code you wrote, making sure to cover the following test scenarios. So for 1, for the function created as the answer to question 1, verify that your code works with different multiplier values, minimally including 0, 2, and 5. And your code works with different lists, including lists with varying sizes. So I'll slide assignment 8 over here. Remember, question 1 was to write a function that accepts 2 arguments, a numeric value, as well as a list of numeric values. This function will be used to multiply each value in the list by the number passed and return the resulting list after this multiplication has been applied. For example, if I gave inputs 2 and 1, 2, 3, 4, 5, the result would be 2, 4, 6, 8, 10. So that was question 1. I want you to write some unit tests for that question here and minimally cover these 2 testing scenarios. It should work with different multiplier values, minimally including 0, 2, and 5. And your code works with different lists, including lists with varying sizes. So, one with like 5 elements, another with 10, all that good stuff. So for the function created as the answer to question 2, and recall question 2 was writing a function that converts a temperature entered in Fahrenheit to Celsius. You want to verify, I want you to write a unit test that'll verify that 32 degrees Fahrenheit is converted to 0 degrees Celsius, 77 degrees Fahrenheit is converted to 25 degrees Celsius, and at least one other test scenario. Any other test scenario, but include at least one other. And then for 3, for the function created as the answer to question 4, so we're skipping over 3 here and going to 4. 4 was the question about creating your own factorial function. So for the function created as the answer to question 4, verify that 0 factorial equals 1, 4 factorial equals 24, and at least 3 other test scenarios. So make sure to cover 3 other test scenarios, and as well as these 2 specific test scenarios. For question 4, for the function created as the answer to question 5, which recall was the function that can convert between US customary units and metric units. I want you to verify that the units passed in feet are converted to meters, units passed in inches are converted to meters, units passed in meters are converted to feet, units passed in miles are converted to kilometers, units passed in kilometers are converted to miles. I think I might have already said that. Units passed in fluid ounces are converted to milliliters. Units passed in milliliters are converted to fluid ounces. Units passed in gallons are converted to liters. Units passed in liters are converted to gallons. Passing 1 foot returns 0.3048 meters. Passing 12 inches returns 0.3048 meters. Passing 3,048 meters returns 10,000 feet. Passing 1 mile returns 1.6039 kilometers. Passing 1.6039 kilometers returns 1 mile. Passing 1 fluid ounce returns 29.574 milliliters. Passing 30 milliliters returns over 1 fluid ounce. I don't know why there's a but there, so let's get rid of that. Passing 1 gallon returns 3.7854 liters, and passing 4 liters returns over 1 gallon. And then as a bonus, this isn't required for the assignment, but as a bonus, update the function from question 3. So remember, the function from question 3 was about it accepts arguments corresponding to the current temperature in degrees Fahrenheit or Celsius, an indicator telling if the temp is in degrees Fahrenheit or Celsius, and the current weather must be cloudy, raining, or sunny, and prints out that the caller should wear what the caller should wear based on these values according to the following. So as a bonus, take that function and update it so that it returns instead of printing the recommendation. So it would return the recommendations instead of printing them out to the console, and verify that both 30 degrees Fahrenheit and -1 degree Celsius return it is probably best to stay in today. And then for B, verify all testing scenarios you can think of. So since this is a bonus question, I'm not going to list out every possible testing scenario that you should cover, but I want you to try to think critically about this and figure out, what testing scenarios you should probably cover, considering combinations of temperature and weather and anything else that would produce distinct outcomes. Any questions on the assignment for the week? Cool. All right, so is there anything you wanted to see demoed from what we went over today? We have a couple extra minutes. I'm just going to fix this here.
Hello, David.
Hey.
Just a quick reminder, I didn't actually get the screenshot of the correction for the last two assignments.
Yeah, so I forgot to send that out last week. I'll send that out I'll send that out today along with the screenshots from today's assignment.
All right, thank you very much. I appreciate it.
Yeah, of course. Thanks for the reminder. So anything in particular you wanted to see demoed? I mean, I showed here, like here, let's just, real quick see what happens if I did want to show you what it looks like. So this is what it looks like running from the command line. But if I run it from the console, you see here, it's not as helpful. So this is saying can't open file, assign 10. Oh, oops, I have the wrong file selected up here. So, oops. So I need to select that file. And then this is what the output looks like here. So it's, I get failure, I get a traceback here, which, it gives me more details on the traceback. It gives me this assertion error. Oops, I am actually not on the right program, sorry. So if I run that there, it'll say the test ran okay. So that works well enough. Let's go with the get user greeting. So it just gives you less detail here, less detail in here. If I make it fail, so if I go to like here, and then I try to run that unit test function up here, it's got like expected, actual, click to see difference. Like this is just hard for me to read. Yeah, so this is something that you want to consider here. This is just what the output looks like. We have like assertion failed. It's a lot more noise essentially. Whereas if I in the terminal, if I just run my unit test for test program.py, here I think this is a lot more readable. It just has failed. It tells me which test failed, and it says expected quotient of 3, but got, I don't know why it's outputting 3 there. Oh, that's right, because it did get 3. I messed up my unit test in a different way. So if I got 4 here, if somehow my quotient was 4, and then I run that file, we'll see it says here, expected quotient of 3, got 3 because quotient actually is 3, but let's just set quotient equal to 4 here. That's the better way to do it. So if quotient somehow equaled 4, then I run it here. My message now shows expected quotient of 3, but got 4, all that good stuff. Like, something that does help in the run console here is you can like click to see the difference here. And if you have like multiple, like a bigger output here, that can be useful. And it tells you what you expected, what the actual value was, and all that good stuff. It's just a lot more to read through. So I prefer myself to go through the terminal, but it's totally up to you. But yeah, unless there are any questions, I'm gonna go ahead and stop the recording and go over the assignment from last week. So any questions before I do that?